Welcome to CML InfoTech. My name is Muhammad Ali from CML InfoTech. Today we're talking about CCNA IP address for class C, day 4, part 3. You can ask any questions if you have. So class A /8, class B /16. Now we're going to talk about class C. For class A, 1 octet in the network and the 3 octet in the host. Class B, 2 octet in the network and 2 octet in the host. So if I'm writing any examples, let's say 150.1.1.1/16, this is IP, and this is the host portion. So 150.1.host portion becomes 0, will be a network, and the host portion will become completely turned on, which is called broadcast. So when you're writing any IP address, the IP will have first and last. If you remember, when I mentioned IP address start from 0 to 255, I said 0 won't use and the 255 won't use as an IP because these are reserved for the network and the broadcast. So the rest of the address within it will become a valid IP. For example, 1, 2, 4, 3, any kind of numbers. So, and even from the class B, you can see started from 127, but always we refer to have a valid IP start from 128. So that means that the 127, XXX, any value, like a 1, 2, 3, 4 until 255 will be served as a loop back. Loop back in the sense for the self-test. We generally do local host ping test with the local host to test with the 127. To test from within that system or within that device have the reachability. The reachability is being enabled within the system will be addressed with the 127. We will do when start to perform the lab, inshallah. Now we're talking about class C. Class C, the range from 192 to 223. And we have a 4 octet. Out of 4 octets, the first 3 octets are defined for the network. So /24. How do I say it /24? 8, 8, 8. 8 plus 8 plus 8, which is equal to 24 as a host or as a network. And the remaining 8 bits is for the host. So when you're writing any address, keep in mind, the first 3 octets must be matched. Let's say you have a switch, you have a PC, 1. I'm just giving an example as a PC. It could be anything like a camera, access control system, or IP phone, access point. It could be anything, which is the IP network device, a connected free system. When I start giving an IP, I can give anything start from 192, let's say 192.1.1.1. I must need to write 24 because the class C, the 3 octet in the network. So when I'm writing second system IP, 192.1.2.5. If I'm writing something like this or 2.2/24, like here it is 1 in the host, here it is a 2 in the host, but the network portion has changed. What I meant, the second octet, the third octet, 192, the third octet is being changed. So I need to make the first 3 octet must be same to communicate each other within the network. So let's say 192.1.1.2 or 192.1.1. Let's say 10. The last octet, you can give any number from 122.254, which is the valid IP. The first three octet must be same to define the class C network. Let's say if I'm writing one class C network 122.111/24, I can write any number until 254. So 192.1.1, this is the network portion. And the host portion, if it's 0, this is called network. If my host portion becomes if my host portion becomes 255, which is broadcast. Okay. Hope you understood the IP address schema. And this 24 is called prefix length. Prefix length. You need to define this. Hope you, in the real scenario, you have seen some address like 10.1.10.0/20. This is actually class A. So here it must be 8, but you can see somewhere in /24. Or even you can see 10.1.10.0. It must be 8, but you can see even 6. So what we learned until now, it's a default IPv4 address. Or we can say class full IP address. So there are two, class full and classless. We have IPv4 in two areas, class full or default, which is class A/8. This is /8, and class B /16, and class C /24. This is called class full. And we have classless, which means there is no class A, B, C. Like in classless, we have two. One we called subnetting, one we called supernetting. In class A, by default 8, if I'm writing from 9 to, in class A, if I'm writing from 9 to 32, subnetting. If I'm writing backwards from 7 to 1, that's called supernetting. It's a short summary. In class B, the default is 17, so 16. If I'm writing from 17 to 32, it's subnetting. If I'm writing from 15, the backwards to 1, called supernetting. Same as class C, the default is 24. If I'm writing from 25 until 32, subnetting. If I'm writing 23 until 1, called supernetting. It's just a summary from the classless. Once we start doing class full default IP, then we can learn more about classless and we can start lab on that specific chapters. Hope you understood. Now, there is another small chapter talking about private IP and public IP. There's a huge story. How come the private IP and public IP came to the market, came to the reality, came to the world? That we can discuss in the later. The public IP means you will have an internet. The private IP in the sense you do not have internet. Okay. In every class, there is a private IP. Let's say in class A, whole 10 range, 10xxx. Anything if you write in 10xx, you will not get internet. In class B, you have 172 network, which is class B. In class C, you have 192, 168 XX network. Why do we need a private and public IP? They're defined in this way for the security purpose. Let's say if I don't have this scenario, like a private and a public IP, you know, the IPv4 is 32 bits. Okay. If I say 2 bits, what is the value? 4 numbers, 2 raised to 2. If I say 3 bits, what is the total number? 2 into 3, 3 times of 2, which is 8 bits. 8 numbers. What if I say 32? 2 raised to 32 number, which means 429496 429496 7295. Yes. 4294967295. This is the outcome when you do 2 raised to 32 value. So DD at 100 like 42 crores. Wow. Are the IP address. In this, if there is no private and public concept, if I need an internet, I'm standing here, I have a laptop, I need an internet. I have to be a part of the public cloud or public entity or on the internet site. So I'm going to get one IP. Let's say 200.735. This this 32-bit are from class A, B, C, D, E, and 200 is from the class C. If someone else need an IP address or need to go on internet, they have a device, need to have an internet. They also need to connect it to the internet, right? So they're going to get another IP, 200.736. Somewhere other people on the other side of the globe who have connected to internet, you also have a device, need an internet, also connected to the club. They may get some other number. The way the total number is 4294967294. Once any person who connected to the internet and who received an IP cannot give that IP to other people. So it's been unique. So which means people, by giving this number 42 crores or 492 crores of people who can connect to the internet, what if the more people come to have an internet connections, who need the internet? There is no free IP address. They cannot connect it. That's the one reason. There is no more number. If I'm giving all the numbers directly to the end user to connect it to the internet, there's no more numbers to connect. And secondly, the people who standing the other side of the globe can connect it to these people because they are directly connected. Give me seconds to behold. We'll continue after the other. Okay, so the question is that one, there is no more IP can available after completing this coverage, this numbers. Secondly, there is no security. People who can communicate each other with anyone, and a person by himself, herself have more than 1 or 2 devices to connect. So the address cannot be enough. One, address shortage. Second, the security. Therefore, they made a private and public, which means I have an organization wherein more than, let's say, 250 employees. Okay, my switch, you can consider my core switch, access switch. Access switches spanned across my my office and connected my 250 employees into it. And need an internet wherein I'm getting the internet from the service provider, let's say Vodafone or QTEL or any respective service provider who are giving the connections to our office. This will be connected to through the firewall to filter the traffic and connect it to my network. When an internet coming to us, I have a single public IP, which lists, for example, 275.32.8 is my public IP. So According to an ISP or service provider, they have a one connection given to us, and I may have more than n number of employees who are sitting in my organization. The way in any of the other globe and any of the other globe, this has spanned and connected to UK, and they have a local UK ISP which connected to their one of the end user or the customer. They connected the firewall and the switch, and there is a load balancer or the E5 or the Splunk, whatsoever, which is connected to the core end side, which again come to the access switch side through either Wi-Fi or the wired, then connected to the, let's say, 500 employees. Okay, so where I have a private and public IP, let's say the private IP under the organization and public IP in the ISP side. So here, if I'm giving 192, which is one of the public IP, 192, let's say 250 address, or if I'm giving 10.0.0.0/8, I have a 2^24, which is this portion of host availability. The same 10.10 range, I can give it here as well. There's no conflict. So this whole 10 range will goes to the other side by converting into 200. So when a packet traveling from my client side through my switch, through my firewall to the ISP and going to the other side, as I said in the very beginning, if I'm giving the same range to multiple systems, this will be conflict, cannot be accessible. But here I'm giving the same range, but they're passing through the ISP. So when my data going out with the 10 range, that will be converted into a public IP, which is 200. So going outside, no one can reach to my internal set of IP because the IP is being changed. So there's going to be security. And secondly, because of unknowing my internal IP, the same IP can be used the other side of the people as well. So there is a device, either could be a firewall or it could be any internet respective product will do that service, convert my private IP to public IP and the public IP to the private IP. This is called NAT, Network Address Translation. We have a subject independently about NAT and deep lab. We'll discuss more into that. Like we have a private NAT, public, we have a static NAT, dynamic NAT, port address translation, PAT, NAT, multiple NATs, of course, yes. Okay, so you will have in your mobile, in your system or any device, you can see either 192.xxxx IP or 10 range XXX IP or 172X range IP. Still, you are getting an internet because of converting into a public IP by using the NAT. Okay, so therefore, the majority area that you can see 192.168.1.1, my system IP, 1.2, 1.3, 1.4 like this. Okay, hope you understood. Now, if you look into this, you can see here what is the number of IP hosts available. In Class C, you can see that this many network 2 crores, 2 lakhs above. So here we can see that 16,000 of hosts that you can, in Class B, equal, somehow equal host and network you can get it. This is what I said, the prefix line, which is /24 for Class C, to address that IP addresses belongs to which class it is by default. Here it is the private IP. You can see that ABC, the private range address. If you assign this IP address to your system will not get the internet directly until there is a NAT translation. Okay, and this is we can later discuss called APIPA, automatic private IP address, which again the range called 169.254. We'll discuss this later, inshallah. Hope we have run the lengthy session today, but As I said in the very beginning, when we start any subject, it is better to finish the subject on the same day in order not to conflict or not to get any confusion if I'm repeating the same subject on the later day. So, in shortly, we have discussed today. I'll give a brief summary of the session today. We have discussed about IP and binary 2 raised to 0, 2 raised to 1, 2 raised to 0, 2 raised to 1. It's backwards. So then IP version 4 have 4 octet, and each octet can start from 0 to 255. But keep in mind, the first octet will always refer to a specific class, like class A, B, C, D, E, which by going through the given numbers. If any IP, you can see that 4 octet, which you can see any IP start with 1 to 126, it's referred as a class A, which you need to write 8. If you have any IP address, let's say 149, let's say 2, 3, 4, anything. 149 is a class B. Therefore, these two must be in the same network, and it is /16. And if you have like anything, let's for example, 2.9, 573, this is must be /24, and the first 3 would be network because of the class C. Okay. On the next session, what you have the homework, keep in mind 5 different network on each class. So how many network? Each class in the sense we have a class A, B, C. So total 15 network. When you have a 15 network, you will have a 15 broadcast. Each network must be 5 IPs. That IP shouldn't repeat continuously. Like for example, if I'm writing class A, one of the network, for example, I'm mentioning 93. One of the. So it must be class A, 93, one of the network. I shouldn't write 93 IP address 1111. This is one of the IP. 93 1112. 93 111 113 45. And I mentioned that we shouldn't repeat the IP address continuously as like this, because it's very easy. We need to define, for example, 93 111 93 10 7 23 or 100 20 251 like this, because the host portion you can reach until 254. So that will make you more understand or more confusion. That's when you write an IP address, in order you to understand in a very well manner, you need to pick it from the different area. Just simply pick it. Do not think whether it is right or wrong. Pick it up and think whether it's right or wrong. If it's right, right. If it's wrong, share it to me and ask why it is wrong. I thought it is right. So when you're sharing your thoughts, your idea, your understands, so that I can easily refer whether it is right or wrong, then I can guide you to make them right. So when you make more work, more homework, it will make more idea to be clear, and that make more sense to become a more good designer. My aim and the ultimate goal by giving this session to you, that you need to define, you need to create, you need to understand by yourself to define and design a good IP address. When we're giving any real-time scenario to anyone, do not give a simple IP schema. That make more easy for them to break it. If you design anything, the team has to come back to you to understand the design, so that no one can easily define it. That's for that you need to make a more complicated design network in order for you to make sure that I'm having good enough idea, inshallah. Okay, so by reaching until now, we have finished the IP address class. The next session is giving the IP practical lab. How do we define the IP address, inshallah? So hope you understand the session. And I recommend you to go through the given document and the video session and make a more practice. And you can send me WhatsApp, not to the group. You can give me individually. So then later we can post into the group, inshallah. Okay. Hope you enjoyed the session today, and we'll have a next session on the next week, inshallah. So keep in touch with us if you have any questions. Okay. Thank you for being with us, spending time with us, inshallah. So my name is Muhammad from CML InfoTech. Blessing you. Have a good day. And thank you for watching us, inshallah.